with this, so you can zoom in closer, but I think that the first question says, make sure you draw your lines following the drainage, meaning the lowest elevations from the mountain. So I'm gonna come back out just a little bit. Does it look to you like I've got that pretty good there? Or do we need to come out further?
Oh, I see.
No, I think where you were was probably good.
Back, so back in a little bit.
Yeah.
Tell me when.
So we need to draw.
Yep. So can you see where I've got my, see my hand? If I take it up to the top where it says that little plus symbol, add path.
Mm-hmm.
And we're supposed to do one track from east to west. And if you look in the far right corner, you can see my north on the upper right hand corner of the picture. So it's, so that would tell me, oops, let me move this guy out of the way. That if I start, you think about right here and head to the right, that'll give me, oops, see, I can't draw a straight line. Oh well. So there's one. And then another one from north and south that goes through the volcano. So, oh, see, that's wrong. Maybe we have to name it. Cancel. Try again. So move that. So we're going to move to the right. There's one. And let's title that East-West. See how that works. Okay. Oh, it saved the line. All right, now we're going to make another one. And we're going to do this one from the north down to the south. A little straighter that time. Okay, north, south. Okay. All right, so we've got these two lines. We got part of the first answer. Make sure you draw lines through the drainage, the lowest emissions as you come off the peak. Look at the elevation profile for the east-west transect. So I'm going to highlight east and west. And, oh, where did I see? There was a specific thing we touched down here that gave us the the way to make that happen. It rotated. Oh, it was it tour guide? Nope, it wasn't that.
What are you trying to do?
I'm sorry. There's a button that you can push on the left-hand side, and what it does is it takes your drawing and it rotates it and creates a line graph showing the altitude of the entire volcano. Oh. And
so you like right click on the line and press show elevation view.
Right click on the line, show elevation profile. Okay. Ta-da!
Yes.
Can you see how that's going?
Thank you, Darren.
Yeah.
Okay. It looks like I missed the far right edge. It didn't get all the way down on the far right side. Are we okay with that? Or do you want me to do it again?
No, I think we're good.
All right. So, based on what you observe, predict what kind of volcano you would expect this to be. Oh, now I've got to pull up my notes.
Yeah, what kind of volcano?
It's steep, right? So
yes, it is steep and fairly uniform.
That's the composite, right?
Yes, because it's symmetrical and cone-shaped.
Yep.
Steep summit. Yep. And so there's one answer. Question number 2.
We got a
do
screen.
a screen capture of the elevation profile and use that to create an illustration that resembles the kind of architecture you would expect for this volcano. All right, I know how to do screenshots. I'm very proud of myself for that.
I
Oh my
guess.
gosh.
All right, for my computer, it's Shift, Control, Command, and the number 4.
There should be one that's just built into Google Earth. Actually.
Too late, I've already pushed that button.
Yeah.
So this is just supposed to be the elevation profile. So I'm going to do just that. Okay. And then I can paste that here in the middle
I think
of
you can do Shift Command 3 and it does the whole your whole screen that you see.
Yes. Well, I could, yes. But
Okay.
this just asks specifically for the east and west transect.
Okay, gotcha.
So this is an illustration, and then label our illustration. So what,
You have to edit it. You have to like type on it.
something. So remember how the volcanoes had specific labels on them? There was the centerpiece, that came up where the magma would be coming up through the earth.
Yeah.
I don't know how to annotate. Where's line drawing? Too much going on. I almost need a second screen like I have at work. That would make life so much easier.
Yeah, that'd be awesome.
Oh, there's a line. I can draw a line. Or a shape.
You're on a Mac, right?
I am.
You have like opened up through the preview.
I'm actually just on the home. There is insert, and you can insert different shapes and lines.
On the
But
you
you're
like
saying,
put the photo through preview. There's like a toolbox on the right side. You click on that, and you can add text and boxes, lines, and draw.
in preview, page setup, text layout, background.
Well, if you click on the image, whatever it opens up.
I don't have preview. I have review, but that's not.
Never mind. Do what you know.
All right, I will. Well, that's part of my is part of my problem. It's learning as I go. Oh, I lost my mouse. A second. I've got to put it back up here. It's a wireless mouse, and it occasionally decides it doesn't need to talk to my computer. Like right now. Come back to life. So I'm thinking we need to draw something to show the different parts of the volcano. So the very top, where it's at 14,000 feet, that would be where the
crater.
crater would be. Yes, thank you.
You're welcome.
Sorry, I'm trying to roll my batteries because it didn't give me a low battery symbol. Oh, I have my computer back. There we go. So I guess technically I should be sharing a different screen now, huh? I can't get it to draw a line within my line, within my picture. I'm going to go back over to share my screen again and see if I can choose a different screen. Turn back on. There we go. This one. Okay, so I'm trying to draw a line indicating down this direction to show where the different parts of this would be, but I can't get it to Talk to me. Any thoughts?
I was thinking maybe Darren or Jeremy could do it in theirs.
No. What are you trying to do, Teresa?
I'm trying to draw within this a line showing the different things that we see there, because we've got to label the cinder cone.
I haven't been able to do it in Word. I can get it done in, or I've done it in PowerPoint. You can upload that picture in PowerPoint, then you can usually draw over the top of them.
Wonder if it'll let me switch to publishing layout.
I've got the I've got like the cone. I figured out how to label like the pin through the preview thing I was talking about. So I like cone labeled.
So you were able to get a line drawn.
Yeah, I went. You're trying to go through. Oh, this is in like Word. You're trying to do it.
Well,
It doesn't even work.
there's publisher layout. Oh, there we go. You can do it in publisher layout.
Oh yeah, that's good. You got the line. You can sort of.
Yeah. So it needs to come down all the way to the bottom. All right. So this line. Now we need a text box. Ka-choong. Open a text box over here. So what did we decide? The center column is called the
Conduit?
what word did you say?
Is it
Conduit? Conduit?
Conduit. Yes.
Conduit.
Yes. I thought you said the convent. I said, no, it's not a convent. Conduit.
Conduit.
Conduit. Okay. And then we draw an arrow. Oh, this will take me forever. You guys are probably faster than me at this. So this is the conduit.
Mhm.
And what else do we have? We have the cinder cone.
Parasitic cone or
Say that again.
the parasitic cone? Higher?
Parasitic. Oh, pyroclastic.
Parasitic.
I don't remember parasitic. I only remember pyroclastic. What was parasitic? Does anybody remember parasitic?
No.
I
No.
just remember pyroclastic.
Well, maybe that's the word.
Okay.
I invented a new word.
Okay, that's all right. So,
Do you You got the crater on the top?
yeah, that would be like the crater.
Okay.
Oops. My picture moved.
Yeah, they're parasitic cone. It's like a side. It's like
Oh, so would one of
Oh.
these potentially be a parasitic cone over here?
I think
Down in here?
the first one on like the right side
Uh-huh.
I think is the parasitic cone.
Okay.
There's the main one and there's one on the side. Let me look at the Google Earth that I have again. Yeah. Yeah, the first like bump to the side. If you look at the Google Earth, it says Little Tahoma Peak.
Uh-huh.
That would be I think that would be a parasitic cone. No.
Okay. So parasitic, that's the wrong word.
So I didn't invent the word.
No, you didn't. I just forgot that word.
I read it somewhere.
Parasitic. Is that how I spelled it? No,
Parasitic.
S-I-C-I-C, yeah.
cone. Okay. And you said that was this first bump or the one further down? This one?
I can't really see where you're like marking on
So
that.
if you start at the top and I slide down the ramp and then it starts to come back up again.
Yeah, that one.
That one.
Yeah.
Okay. Boom. Like that?
Yeah.
Yeah.
How about this? The cinder cone.
That's what the cinder cone.
The vent. The vent is also the vent's also like it's like in the same place as the crater.
Oh, really?
Yeah, it's like the crater's like the top, and just
Yeah.
beneath the crater is the vent.
Mm-hmm.
Okay.
What other, anything else we want to label on here? Crater, conduit, parasitic cone.
Wow.
How about what about this second bigger rise? If you go all the way down about 15 miles to the right of the peak of the mountain, it starts to go back up again. Is that another parasitic cone?
Let me,
It's at about 15 miles to the right of or 16 miles to the right of the cone itself.
the Cowlitz chimney. Let me see. I think that might be it.
I'd say it's a high possibility. We could name that.
Yeah.
Because it looks like another area here. I wish I could move my picture over. It's not letting me move it over. Oh, maybe it will now. No.
So I think I do see some other ones that are on like the left side of the
Mm-hmm.
So.
Okay. How about on the far left side where it's got that little valley down in the bottom? You think that's anything important?
the little valley area. There is a peak right there. There should be like Aurora Peak.
Is that further to the left that I've missed, or partway up on the far left side?
Let me I'm going through my Google Maps to sort of try to look at that, and then also to your screen.
Mm-hmm.
Oh yeah, you see it on like the. Wait, that's some other screen. Which one is it? It's so hard trying to. I'm going through like 4 different screens. Trying to,
I know, because I'm really missing my work right now because I have 2 big screens that I use at work.
Oh, that's nice.
Mine's going really slow for some reason. We find something, then you guys are already past it. So
I'm so sorry. That's
it's okay.
not the
No,
plan at all.
No, I know. I don't know what's going on. Why it's being so slow.
I think like right before it drops down into the like valley
On the left side of the mountain or the right side?
on the left side.
Okay. So down in.
Like
about 3 miles out, to the left from the far left border, I can see what you're talking about. There is a little tiny bump that comes up, and then it comes down further down at about.
no, like a little bit part like. It's hard to see because mine shows different than yours. Oh wait.
Oh, that's probably because you
Yeah, I have a different.
drew had your mountain closer or further away, and so your line might be bigger or smaller than mine.
I think the bump in the valley, that one bump, like it goes down kind of far and then does a tiny little bump and then it continues going down.
Yes.
Like right before 2.5
Yeah.
mile. I think that's another one.
That little tiny bump you think is another parasitic cone?
Yeah, because I think that would line up with the Aurora Peak that I see on the map.
Oh, okay. So we need another arrow. How are you doing, Jeremy?
Doing all right. Sorry.
No. Oh my, how am I going to try and make that line go over there? Too many lines all going the same direction. It's just not.
This would be a lot easier in person.
Yes, it would. I agree with you there.
I feel like I need like 4 screens. I need to like take my roommate's laptop.
All right. Can you still see what I'm doing on mine?
Yeah.
Okay, I tried to make it bigger so that it was easier to see. I don't know if it made it bigger for you as well or just for me.
Yeah, it's big.
And the whole picture is shifted down.
Yes, because we were, oh yeah, it just did. Probably because I typed that, huh?
Yeah.
Well, just make my life miserable. All right, we'll grab this line and we'll go like that. Good thing I've done this for primary activities. I can, it's the only reason I'm able to make this happen. There we go. Do that. Grab this line and move it down. I'll grab this arrow and move it to here. We'll move this up here. Grab this and we'll make it short. Oops, stay there. Maybe I can't make it shorter. There we go. Okay, parasitic cone. Parasitic cone. What else do we want to label in here?
Maybe the vent.
And which vents do you have in mind?
That just the only vent, like when I'm looking at the anatomy of a volcano chapter.
Yes.
That would just be like the same place as the crater. That's all it's for.
So I can put
Yeah,
crater,
it's
comma, vent.
Yeah.
Okay.
Okay.
Do you want to label the cinder cone?
Well, I guess on this particular mountain, is the cinder cone still there or is the cinder cone gone?
To the crater, right?
Because
No?
I'm thinking like the cinder cone
I'm just gonna look at my
would
notes.
be cinder cones. Cinder cone is a type of a volcano that's a smaller volcano. I don't know that you would have a cinder cone volcano on top of a composite volcano.
Yeah, I think it's just the cone. Like it's the volcano.
It's just the actual crater.
Yeah, I think so. Yeah.
All right.
Because a cinder cone volcano would be much smaller than that and would be fairly uniformly shaped, but it isn't as steep. I think this particular type of a volcano is more like a 40-degree angle, and the cinder cone is a broader, shorter angle. It's only 30 degrees from the ground up. Okay. So I think we've covered that, unless you can think of is there anything we can label about the sides that are sloping downward?
That's just like the next questions.
Oh, okay.
Like it says, which side has the lowest elevation, and what does that mean? I didn't see anything in the notes. I think about about what the column is.
All right. So it didn't ever ask us to compare the elevation for the north-south one, but we should. So let's do the elevation profile going north-south. So this one that I have now, let me switch screens again. Oh, where did you guys go? Oh, you're over here.
Are we supposed to do both?
No, but you'd have to in order to, you'd have to do both in order to compare them. So this one that I have here, can you share two screens at the same time? I wonder if I hit control. Nope, I can't. I can only show one. So this screenshot is a different shape of the volcano because it's showing looking from south to north. As you look from south to north, you can see that the part that's on that now would be southward goes to the right here, and it's a really much steeper drop off. Whereas the part that goes to the north is a lot more gradual.
Yeah.
So I think the question is, what?
I was thinking like, I thought I was asking if the left side or the right side lower. Both profiles. That would sound like it's doing both.
Okay. Because this one says compare the elevation for both transects, but I only see it asking us to do one.
Yeah, so maybe it just says we're only supposed to do all that stuff for one. Now we can just look at the second one.
Okay, we can do that. Which side of the mountain has the lowest elevation? So the drawing that I screen captured first was going east and west. So on that first drawing, the lowest point of elevation that I grabbed is about just under 3,000 feet.
Yeah,
and on the other direction,
it tells you at the top of the graph. Like on yours, it says what for your shows the min, max, and average of the graph. If you see like the red box,
yes, I do.
I'll tell you like which side's smaller. So,
Well,
or I guess we can just read the number, but like which side looks smaller.
yeah,
Like the south side.
So on the one that I'm showing you right now, yes, the south side would be lowest in here, but on the east-west one, the east side is the lowest.
Okay.
So maybe that's what we should put on the, oh, if it'll let me type.
On the Google Doc.
Oh wow.
Yeah, I love to hate computers. Some things are not. On the east, west, the east side. At just under 3,000 square feet. Not square feet, it's 3,000 feet. How are you coming, Jeremy?
I'm still here.
How are things working for you?
Good so far. Just it's just slow.
Okay.
Trying to pull up the material from the book and everything.
It is. It's hard to go back and forth. That's one of the downsides for me of not having an actual textbook.
Yeah.
Yeah.
Well, and then the transfer pages and stuff, like I say, we're, trying to get there, and you guys are already past it, so.
And you need to tell us to slow down.
You're good. So. I have the split screens, but it doesn't make it run faster.
Okay.
So I'm just trying to read ahead on a few questions and then start looking up stuff while you're working on that.
Oh.
Yeah, I'm trying to do the same thing. Just look at questions that I can probably have the answers ready for you guys. Are we still working on 1C?
Yeah.
Mm-hmm.
So from
I think I have it as the south side coming down as the lowest. At least on my picture, when I'm moving it around, I have like the edge of the volcano at like 1,700 meters. And then when I look at the east-west, the lower side I have as the east side. I have that going down like right at the corner at 2,000.
yeah, and I think you got a little bit further than mine because on the east side, because mine only goes down to about 2,800.
Uh-huh.
So from what I could see here, the lowest that I had on my south side only went down to 3,800 feet for my lowest point on the south side. So I think the east side is the lowest point of the mountain.
All right.
Is there a way that you can move the pictures like on like for me to move your guys' pictures in the bottom so I can see the map?
Yes. So
You just like
let me say that question again. So you're saying on your own computer or
yeah,
on?
because you guys.
Right.
Oh, we just lost your microphone. Oh, are you back?
I think I accidentally turned him off.
Oh, unmute him.
Like
Oh, no.
our
Oh, my-
pictures are on the lower right on the
Okay.
screen. It's blocking the graph.
Yeah.
I see what you're saying.
You know, if there's a way that you can move.
I don't
Move
know.
So
Move
I
it.
moved it up higher on my screen. I don't know if that helps you at all.
I just wanted to.
How about if
you
I
raise
move it to the
up.
left? Does that change anything?
Nope.
I'm sorry. How about if I
No, it's okay. I was just trying to be able to see the graph
how
more
about
fully.
if I shrink it up? Does that make it better for you? I shrunk that whole picture. Nope.
No, it's just our pictures are in,
Yeah.
are there
Okay.
on top of the
Okay.
graph. It's okay.
Yours, so I made mine full screen, but it didn't fix anything.
I just thought that
Okay.
it would be a thing and we can click our pictures out, so we don't have to see each other.
Yeah.
Okay. So do you think we're ready to move on to the next question of what consequences could possibly result on the side with the lowest
Yeah.
elevation?
Yeah.
Well, what do you think? What could make that lowest elevation lower on one side versus the other? Could it be that the wind was, or that the volcano erupted more on that side and that the wind was blowing and pushed things more that direction?
I think
Or,
it's going to
Or
happen.
the
Like when it
or lava.
I think it's asking why.
Lava. Right.
okay, you guys try it again and take one turn at a time because then you all clump up and we can't hear you.
Darren, go ahead.
Oh, so like that's asking like when it erupts, like what the problem is going to be, right?
Yes, and maybe some things after the volcano has erupted. This is thousands of years after the last eruption or hundreds of years after its last eruption. And it didn't erupt and be uniform all the way around it. So it might be, as I'm looking at the screenshot that we drew our arrows and labels on, where it's the left side of it is more up and down. It's got a steeper angle, and the right side is more gradual. Maybe that left side is exposed to more wind and other elements, and it changes how
I think that's probably like mud flows occur. Like when it erupts and it gets all hot, all the ice melts, all the snow melts on top, and like mud flows form and it sort of tears down the whole side.
So I changed the screenshot. Can you see the change that I made? So you're saying that on that left side of the picture that we have, that's more upright because there's more ice and snow that has maybe eroded down part of the mountain?
Yeah, like me, like because it's so steep, that's going to be a problem. It's going to wear down more because it's going to have all the snow that's built up there when it erupts. It's so hot, it melts all instantly.
Okay.
And it'll cause the mudslides down the whole volcano. And since that one's like, there's nothing on the right side, it's got sort of stuff to catch all the mud falling. It's got other peaks and stuff. The left side is it'll just all drop straight down.
Okay.
It is also going to have more erosion.
So more erosion. do you think that the fact that that side faces east and the other side faces west, so where I live up here in the Northwest, during the winter time, to get sun into your home, you kind of hope that you've got windows on the south side of your house, because the sun actually drops down lower on the horizon and comes more sideways around from east to west. So the west side of the mountain would be getting a lot longer sun exposure than the east side of the mountain would. That same thing would be true for the south side of the mountain on the other screenshot as well, wherever that went on my computer. Yeah, so when I'm looking at the other version, the north-south one, the south side of the mountain is a lot more straight down, and the north side, which would get less sunlight and warmth from the sun, I don't know, it's still pretty steep though. All right, anybody have any other ideas besides or in addition to more ice and snow shearing off part of the mountain on the east side? And more erosion. Do we want to talk about the possibility of, oh, you know what? We've got those additional parasitic cones up on the west side of the mountain too. So that could, as those are erupting, that could add more material to the west side of the mountain to make it be less steep.
Yeah,
What do you think about that?
that makes sense.
Yeah.
So those would add more surface material.
Yeah.
Yep. I would agree there.
So how about on the lowest side of the volcano, because of the gravity, when all these lava and materials from the volcano are exploding, because of the gravity and being so low, it's sending tons of ash and materials from the volcano really fast downslope.
Yeah.
Good idea.
It's like the pyroclastic flow is
It
driven.
might be more destructive then, right?
Yeah.
The book says, like, talks about the pyroclastic flow and how it's driven by gravity. So since that's steeper, the pyroclastic flow will be moving faster, and it'll just sort of like take out all the trees in the way and all the stuff that was sort of.
Exactly.
And it would cool. It would still be hot as it's moving down because it's a steep slope, right? Which would increase the speed that it's moving, because when they're cooling, that's when they slow down their movement as they're cooling, right?
Right. Yep.
And it has less barriers too, because there's no obstacles. It's just
Yeah. So it's going to
Going
flow
down.
faster. Yep.
It'll just pick up more and more speed, and then so the things it'll hit will slow it down less and less.
So it would be more fluid because it was hotter. Stay fluid longer.
I've got to leave in like 10 minutes max. I just
Okay,
Okay.
we best move along.
okay. Yeah. How many other questions?
Several. What type of volcano would this be, and the potential hazards that exist?
yeah. So I guess that would be the pyroclastic flow and mud flows.
Yeah. Would
Yeah.
you put that on on that one?
Yeah, it'd be coming down a lot faster, Adam. Or at
Put it
Mhm.
down below. Yeah.
Uh-huh. And we talked about this
Gauge
being
velocity.
for this composite volcano.
What?
We predicted it was a composite volcano. Based on that answer, what rock types might you find in this area? List all that might apply.
Mhm.
Composite volcano.
There could be some pumice.
Yeah.
Yes. Yes.
Pumice. Could there be some basalt?
Yeah, absolutely.
Mhm.
What other rocks would be coming up through the volcano from?
It was silicon rich. That'd be like granite, right?
Yeah.
Granitic. Yeah.
I'm sorry. What was the other one you just said? Jeremy?
I just said the granitic.
Yes.
A bunch of
Oh, yeah.
types.
Mm-hmm. Felsic material, the rhyolites and
Yeah. Yeah. Rhyolite. Got another paper I got from the lab section of the class.
oh yes, we're so glad
Have
you're in.
another
We're so
from
glad
the
you're in the lab. Thank you for being in the lab.
Yes.
Oh, did you forget to send us the other one from last week?
Actually, I sent it to him. I remember to send it to him.
Yeah. Yeah, he asked me to ask you to send it to him because he was going to send it out to the group, but I hadn't seen it yet.
I sent it to him. I
Yeah.
thought,
Yeah.
sorry, I should have sent
Only to him.
All right. While you're looking at that, what are some of the other geologic features that we see in this area on this mount of this volcano? Well, there's deep valleys where the lava flows and the ice have
We got any lakes around there?
let me zoom back out. Not up on the top side.
I see a lot of like runoffs on the north. North.
It's got runoffs on all around the mountain.
Yeah, a lot of water runoffs. You see like the rivers sort of falling off, going away from it.
Could those be from glaciers that may be melted?
I think that'd be from like the water, the ice, snow melting. Probably, right?
Probably from both. Probably from glaciers and snowmelt.
Yeah.
Yeah. Yep.
Do you think that the ash or the lava could have caused part of that as well? That carving out of the mountainside?
Yeah.
Because it might melt some of that surface area as it's scouring down the mountain.
Mm-hmm.
Mm-hmm.
What kind of volcano is this volcano close to any tectonic plate boundaries, and how far away is it from them?
Yeah, it's near the North American plate and the Juan de Fuca.
Yeah.
I don't know exactly how far.
Can we zoom out?
Yes.
Can we see those? Is there a way to show those?
The fault plate or the plates.
Yeah.
That's back in like a couple of chapters ago, wasn't it? Like in 2 or something.
There's an additional app that the teacher put on here on his.
Oh, yeah. Actually,
Oh, great. Yeah.
So I'm going to close that
Oh.
out.
Strait of Juan de Fuca. Oh, never mind.
Yeah, the plate of Juan de Fuca is down in here. Can you see my screen? It's got this little zigzaggy stuff here.
Yep.
Where's that ruler? Oh,
Right there. Yeah.
all right. Measure the distance between 2 points on the ground. Between here. Oh, we have to draw our points first.
Yeah. You just click. And then, yeah.
But here and there. Save. That's not how you spell that, but you get the idea.
Mhm.
So what's the distance? Anybody know how to make that happen?
I think go down to the line and do the elevation profile.
Down here, elevation.
Yeah, like
Okay, so from,
So that's,
Well, that's-
the Mount Rainier, and then go all the way down to the side. I can't see down there, but wherever.
that's all right. This says 393 miles. If I started at exactly the right location on the mountain.
Mhm.
So 400 miles, that work for you?
Yeah.
I would say that.
Okay.
That works.
400 miles.
That'd be a subduction. Oh, that's the next question. I'll let you finish that.
Yeah. What kind of tectonic boundary?
That'd be subduction, right?
Yeah.
Foundation.
Well, by convergent, isn't it?
Subduction
got-
and inversion. Is inversion, that's the one where they're sliding side by side, right?
Well,
the
but we have,
subduction-
isn't it one's going under the other? The oceanic is going underneath the American. The Juan de Fuca is going under, so isn't it convergent?
So
Yeah, convergence,
Am I-
subduction are the same thing.
But it's by subduction, yes.
yeah, it's it'd be a convergent zone is what it'd be called.
so there's
A boundary.
so the Juan de Fuca plate where it meets the North America plate is a subduction zone.
Mm-hmm.
But there's also areas where the two meet that it is inversion where they slide. So this is where they're sliding,
Uh-huh.
right? But there's also, I think here, or maybe it's further out,
What is the lighter color? Is that
that's the
just
ocean.
is that
that's-
just depth wise,
that's
or is
the-
that
It is, but I think that's also showing the edge of the continental plate there.
okay? So,
So-
that's not the Juan de Fuca in the American.
This would be the one of Fuca edge where it meets is this the Pacific?
Yeah.
Yeah, and this would be the one of Fuca where it meets the continental. So there's like two. So we're,
Well, I would say it's that second one, the where it meets the continental, because that's the one that's going to have more of the effect on Mount Rainier, right?
Yeah.
Because you got the subducting going underneath it, so then it's
so that would be smaller than 400 miles then, because that's closer.
yeah. That's my thinking on it.
Delete. And how did we? Oh, Darren's got to go. We got to hurry.
I'll stay until we finish. I think I'll probably be fine.
How did I do that again? I don't even remember.
You trying to see the distance?
Yes. What did we do? Oh, the ruler.
Yeah, the elevation profile.
Maybe just draw another one if you get it.
So there's a line path from here.
I think if you just draw like a really long line coming out of the Mount Rainier.
Like that? Like that?
I think like if
Yeah.
you draw like an even longer one, you can really see where the elevation changes. You can see where it drops for the plate.
Okay. So we can, oops. That's not what I wanted. I wanted this one. All right, right click on this and save. Close. All right, technology is my friend. Technology is my friend. It is.
You're lucky. It's not my friend.
No, I'm trying to tell myself. Power of positive thinking. Technology is my friend.
I'm
See, it's-
positive it's not my friend.
See, it's not letting me. Oh, it's because I'm trying to click. It doesn't like you to click. Save. Okay. Mine too. Okay. So right click on this line, show elevation profile. So that point is,
161 miles.
yeah,
Okay. Sweet.
what kind of tectonic boundary? We decided that was a subduction
Mhm.
at that location.
Oh, it's a
And
converging, right? Because they're it's tied together, isn't
converging.
it?
Yeah, it's a converging one that subducts. Yes.
Yes.
Thank you.
No, you're good. I just want to make sure that I was understanding it correctly. That
Yes. What direction do you think it is moving relative to North America?
It's moving southeast, like diagonally.
The plate, so the Juan de Fuca plate is moving southeast,
Or the
and North America is moving northward? Or is it the other way around? I think North America is moving south.
yeah, that's what I meant to say.
Okay, no, is that what you guys remember too?
Yeah. Moving
Yeah.
south.
Do you think there's any relationship between the tectonic setting and the occurrence of Mount Rainier?
Yes.
Okay.
yes, definitely.
And why?
Uh,
So as the plates converge, what happens?
Yeah, as the oceanic plate subducts underneath the continental, then that was just like a weak point where you'd have the magma, the pressure building up, and so
yeah,
up through the crust.
yeah, it melts and pulls up through.
So as it's doing that, so remember we talked about how the heat would then radiate upwards from that
Mhm.
subduction zone, okay?
Yep. And at those points is where there's the most pressure, so that's where it would, or it could, I guess, not necessarily be the most pressure, but could be kind of a spot where it could
Convex,
follow.
conduit,
Yeah.
what was the convection?
Yes.
Convex the heat upwards to add more pressure to build the high.
Yay, my Google Earth is working. It took just an hour.
So sorry that took so long.
It took
And-
just about an hour, gosh.
Are there other
Congratulations.
noticeable volcanoes in the area with them? And what
Yeah.
similarities or differences do you notice about them?
It's like,
Okay, close that.
right?
So here's one.
We got Mount St. Helens,
Yep, so let's start
Um,
listening.
got Mount Rainier, got
One a week.
Mount Hood.
Yep,
And they're all combined,
Adams.
right?
What was that, Darren?
They're all composite volcanoes as well, right?
Yes, from what I
I
can
would say
see.
so.
Yeah, and they're all they're all from the Juan de Fuca and North American plate or the Pacific plate meeting, or the Juan de Fuca and the North American plate. I mean.
And they're in a continental arc, right?
Yes. Yeah, good point.
North America. Okay. But so there's several mountains here. I have to say that. So let's.
Yeah.
So how am I going to see the names of these other mountains? Thoughts?
Uh,
Will it show if we just click on them? No?
I think the more and more you zoom in, I think it shows more and more of them.
Okay.
Uh,
Okay.
Oops.
So I got,
I almost wonder if it's where you typed in your search, where you typed in Mount Rainier instead of like just in that general area.
I've got
But if
How about Pacific? No. Get rid of this other stuff.
yeah,
Well,
I like,
in my screen, it shows a tour guide, and it shows a lot of other mountains.
So you hit that map down at the bottom where it says tour guide.
Yeah.
So Mount Rainier, there's a couple of versions of that.
And I have Little Tahoma Peak.
I
okay,
think that's part of Mount Rainier though, isn't it?
Okay.
I don't know.
Little Tahoma Peak. And how about Pinnacle Peak?
Those are all parts of Mount Rainier.
Okay. And Crystal Mountain?
Yep.
All part of it? Okay.
oh, here we go.
Pacific
Okay.
Northwest. So what
We
did
got-
you?
We got Mount Baker, Mount Rainier,
Okay, Baker.
Mount St. Helens, Mount Adams,
Where are you finding all those?
Google. I just on Wikipedia.
Oh, thank you. So you're not using the Google Earth then? Okay.
No, Mount Hood.
yeah, Mount Hood and Mount Jefferson.
Okay.
Are those all within a few hundred miles?
Yeah.
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 Yeah,
Is-
Mount Hood is,
Is Mount Jefferson? I thought Jefferson was further south and east.
Yeah.
Am
well, I guess Baker would be quite a ways up north. It's like right on the Canadian border.
I think it's
So-
like, I think it's like more of Mount Adams and like Mount Jefferson that are pretty close.
Yeah.
So Jefferson.
Adams.
Yeah, I'd get rid of Baker's.
And then I gotta go.
All
Okay.
right. Thank you. I think we've got enough. We could finish up some of the similarities and differences after you close it out. Thank you, Jeremy.
Yeah, you bet. Thank you guys.
So who's gonna
Oh, Darren.
who's gonna post?
Yeah, I'll put it off and I'll email you guys right now. I got the link.
Okay.
We got
So what about our notes? Do you want me to use the ones that I typed up? Do you guys want to look at them and I can put them on?
no, you good. Yeah, you did a great job. You just
Yeah.
I've got to reformat the numbering of the questions. That's